Okay, so day 2 here, we want to think about probability and relate it back to all this set and Venn diagram stuff that we've done already. So look at this example. It says, let E and F be two mutually exclusive events, and suppose that the probability of E is 0.1 and the probability of F is 0.6. Compute the following. The fact that they're mutually exclusive, remember, means that they have no intersection. So the probability of point E happening is 0.1, and the probability of point F happening is 0.6. And so think about that as you're doing this. So for A, what's the probability of E intersect F? Well, if there is no intersection for E and F, the chances of that happening, of both of them happening at the same time, it can't happen, right? So that's the probability of 0. What's the probability of E union F? Well, that's just the probability of E plus the probability of F. So that's just 0.1 plus 0.6, which is 0.7. For C, what's the probability of E complement happening? Well, think about E complement means the chance of E not happening. So that's just going to be 1 minus the probability of E happening, or 1 minus 0.1, which means if E only has a 0.1 chance of happening, then E not happening has a pretty good chance, right? 0.9. Come over here. For D, what's the probability of E complements intersect F complement? So this one maybe we got to think a little bit more about. This one is, gosh, 9 and 0.4. This one, the book says we should go back and think about De Morgan's law. So what about this? Like in De Morgan's law, we learned that E complement intersect F complement is the same as E union F complement, and that's going to be a lot easier to compute. I'd like you to think about to see if you could figure out how could we compute this if you didn't remember this. That's what I'd like you to think about. But if this is true, there's a law that says this is true. So we already know that E union F is 0.7, right? So the complement of that would be 1 minus 0.7, which is 0.3. Can you use just this and figure out if it's 0.3? I want you to think about that. And then look at E. Again, E goes back to that De Morgan's law. But also E, I think E I can do much easier without De Morgan's law. E complement union F complement. Because it's union, the chance of E not happening and the chance of F not happening, right? Or F not happening would be like everything. So like the biggest probability you can have is 1. So the answer there is that it has to be 1. But De Morgan's law, how could I show this as an equation? De Morgan's law says E complement U complement is the same as E intersect F complement. So it's like when you move the C to the outside, it flips this around. And we know E intersect F was 0, so the opposite of 0 would be 100% chance of it happening. Okay? So this is a little bit tougher, I think, when they just give you this and you have to kind of relate it back to set notation. I didn't notice that there was an example 6, and so you need to do this on the back. The back side of your notes is empty, so I want you to write this out on the back. You don't have to write down all of it, but just maybe write this. The probability of E is 0.2. The probability of F is 0.1. And they're telling us that E intersect F is 0.05 probability. And then they asked us to compute these probabilities. And it says, hint, draw a Venn diagram. This is not mutually exclusive. If there's an intersection, it's not mutually exclusive. So I'm going to draw that Venn diagram first. So this is E and this is F. I know that the intersection probability is 0.05. So think about that's going to change. If the probability of E happening altogether is 0.2, I have to subtract 0.05 for it. So now just E alone's probability would be 0.15, because together that has to add up to 0.2. And the probability of F happening is 0.1. So if I subtract 0.5 from that, that means that this would also just be 0.05. So be careful with that, right? Also, I feel like maybe this will be the key to the other one. If this is the chance of E and F happening on the outside, what could I do to figure out the probability of E and F not happening? Well, I could take 1 minus these, right? Because it has to add up to 100%. So this would be 15, 20, 25. So I think that means there's a 75% chance of it not happening out here. And I think if we go back, I think I've just figured out this one. How could I get 0.3 if I didn't know De Morgan's law? Well, this is 0.1 and this is 0.6. That's 0.7. So the chance of it not happening would be 0.3. That would be the outside part. Here we go. I just learned something. Because this is S. Okay, so part A says, what's the probability of E union F? Again, be careful here because we have this intersection, but either you can just add these three across, or you can take the probability. Here's the formula. It's the probability of E plus the probability of F minus the probability of their intersection, right? So that would be 0.15, or sorry, if I do it this way, it'd be 0.2 plus 0.1 minus 0.05, which is 0.25. You also can just add these three numbers. Add just E, just the intersection, and just this, and you also get 0.25. For part B, it says, what's the probability of E complement intersect F complement? Again, if you use the Venn diagram, I think that it's helpful. If you don't know De Morgan's law, what's E complement? E complement would be not E, so that would be 0.05 and 0.75. What's F complement? Not F would be 0.15 and 0.75. But what's the intersection of that? What's the only part they both share is that outside part. The chance of neither one happening is 0.75. Again, De Morgan's law says this is the same as E union F complement. And so another way to do that is that you take 1 minus what we got in part A, which is also 0.75. So again, it's kind of up to you on how you want to do that here. I feel like the Venn diagram helps a lot. I think part C is the one they gave us the hint to draw on. It says probability of E complement intersect F. Again, going back to unit 1, E complement, if I do a highlighter here, E complement would be everything not an E. So that would be this and the outside part, right? And F would be just F, which would be, F would include this and this. So where's the intersection of that? Oh, that's a highlighter. I think the intersection is just what's just an F, right? Which is just 0.05. And so that's where that Venn diagram life is coming back to us, and we're going to practice this in class.